Hi, my name is Sung Tae-moon. I'll talk about Drone 2020 models for the object detection in image challenge. Before explaining main topic, I hope to introduce my team members and object detection in image challenge briefly. Our team consists of a total of 5 members from Korea and Sungkyunkwan University. Our team has participated in the VisDrone competition since 2019. So this is the second try. In this workshop, we participated in object detection in image challenging track called DET. The DET track solved the problem of localizing multiple object categories in the image. For each image, algorithms are required to locate all the object instances of a predefined set of object categories. The VisDrone dataset mainly focuses on 10 object categories, including pedestrian, person, car, van, bus, truck, motor, bicycle, tricycle, owning tricycle. The TET track requires the detection algorithm to predict the bounding box of each instance of each object class in the image. The DET dataset includes more than 10,000 images in constrained challenging scene, including training, validation, test challenging, and test depth subset. Next is the analysis of a VisDrone dataset before explaining the model. The DT dataset has extremely small-scale objects. All individual images are taken by drones in the different view angles. As a result, the VisDrone dataset is different from existing dataset like COCO dataset imaging. VisDrone dataset is one of the largest dataset taken by drone in the world. However, I think that this dataset has limitation. First, the number of objects for each category is imbalance compared to COCO dataset. Car and pedestrian occupy more than 65%. On the other hand, tricycle and owning tricycle occupy less than 2%. Second, the some categories are very similar. The feature of the pedestrian and people are similar. More precisely, the pedestrian is included in people. Like that, van, truck, and bus are included in car categories. Third, the training image dataset is insufficient to train complex model. So, Drone 2020 models focus on how to detect a small-scale object, how to increase the dataset, and how to balance the object count. To increase the dataset, first, we simply use horizontal flip. We can double the dataset. Second, we split image into patches to train. In this case, we use 2x2 patch. Each patch is scaled up for training. Third, to overcome imbalance, we use the pre-trained model using COCO dataset, so we can increase the number of image dataset. The training model is constructed using detector RS based on cascade RCNN to detect a small-scale object. This model used the three-stage detection to satisfy the high-quality object detectors. This architecture can avoid the problem of fitting at training and quality mismatches at inference. For backbone networks, ResNet 50 is used. Actually, the ResNext 101 was tried. However, we can't apply it to the model in the competition because of the limitation of GPU memory and due date. In addition, the switchable Atheros convolution is used. As you know, Atheros convolutions are the operation that increase the field of view without any additional computation. However, the fixed receptive field has a limitation to understand the object. So, the switchable Atheros convolution is used to solve the limitation of a fixed receptive field. With the switchable address conversion, the recursive feature pyramid is used in detector RS. The recursive feature pyramid adds a feedback connection in FPN to look at the image recursively. The RFP recursively enhances FPN to generate increasingly powerful representation. For testing, we use the multi-scale testing approach to enhance the detection quality. For that, we use 7 types of scale, keeping same ratio. Even though this image size is just larger than the original while keeping resolution, it has excellent effect to enhance the detection. And software NMS is used for the robust object detection about overlapped object. Finally, in general, the maximum number of detections should be limited for one image. In case of the VisDrone, we assume that maximum number of objects is 500 because the VisDrone dataset has a large of objects in an image. Next is experimental result. Before explaining experimental result, I will explain implementation in detail. For training, we trained 12 epochs, and each patch size is resized for training. And for optimizer, we use SGD optimizer with momentum 0.9 and weight decay like that. For the running rate schedule, we use step decay approach. So we can reduce the running rate according to the epoch. For running, we use the full NVIDIA RTX Titan GPU and detection toolbox, which is implemented with the PyTorch is used in Ubuntu. To improve detection performance, we try to test various models. As a result, we found the image resolution is very important to improve detection. And software NMS and max detection change improve detection performance by about 2%. In addition, the detector RS, which is a software algorithm, improve the object detection performance with multi-scale testing. So as a result, finally we get 37.33% in test depth dataset. The final experiment result is like that. For demonstration, we used static images and video clip. In case of a static image, we found that lots of objects are detected like that. The experiment result of a video clip is like that. However, the play time is modified because the inference time is not enough to detect the video in real time. The Drone 2020 algorithm used a multiple scale testing approach with the software NMS to improve the object detection performance. The splitted image is used for the training, and I found that the algorithm based on cascade CNN is useful for the small object detection. To improve the performance of detection, I will try to use the ResNest 101 and try to use the various sort algorithm. Finally, I will hope to reduce the inference time to apply to the real drone system. Thank you.